Ladies and gentlemen, I wish you all a very good day. My name is Vincenzo De Florio, and it is my pleasure to welcome you to today's presentation, whose title is Preliminary Contributions Towards Auto-Resilience. My speech is organized as follows. First, I'm going to present you a number of questions, some reflections, and some ideas about resilience. Three are the main questions that I focused on. What is resilience? What makes a collective or individual system resilient? And once we have given a tentative answer to the above questions, how can we make use of the accrued knowledge to design resilient systems? In what follows, I will use the term essence to refer to an individual or collective system, natural or otherwise. Major goal of this work is to begin a discussion about optimal ways to reach and sustain resilience, for instance, through autonomic management of the resilience subsystems. A first question is, what is resilience? Resilience is the property of an essence that is able to retain one's identity throughout context changes. This concept is far from new. It actually dates back to Aristotle, who called it entelechy. Many a scholar have written on Aristotelian entelechy, and this is not the venue to indulge into this matter, but I think it's interesting here to recall at least Joe Sachs' translation of entelechy. Sachs says that entelechy is two things: being at work, staying the same. I interpret these two abilities as being able to adapt to changing circumstances without compromising one's peculiar characteristics. In Aristotelian terms, this means without breaking down one's definition. A second key question is, what makes an essence resilient? My conjecture is that resilience is the result of several different abilities that must coexist within the same essence. Said optimal coexistence is indeed a non-trivial design problem, requiring the appropriate definition of design trade-offs. Nature provides us with many examples of this, and many ingenious ways to overcome design limitations. See, for instance, Nilsson for a few great examples of this. A major conjecture in what follows is that resilience consists of a mixture of the following three abilities: perception, apperception, and entelechy. I believe a first prerequisite to resilience to be the ability to perceive, the ability, that is, to timely register the state of some subset of the context figures. I decompose perception into three sub-services: sensors, quale, and memory. Sensors represent our primary interface with the physical world, in that they open up to a subset of the world's raw facts. We have several problems related to the sensor layer. First of all, our view is incomplete. The famous opening to Coleridge's rhyme reminds us that most of the context figures remain invisible to our perception. Other problems are related to the encoding process, to external dependencies, think for instance of battery depletion, and of course to the effects of aging. A second perception layer is the one responsible for the creation of so-called quale. A qualia, plural quale, is an internal representation of a raw fact. This can be represented as a morphism from set U, the physical world, to set C, the computer world. Also in this case, we need to consider different aspects affecting resilience. For instance, the time required for a qualia to manifest itself, or the amount of raw facts that can be qualified in the unit of time. The third perception layer is memory, responsible for the storage and retrieval of quale. This is also a key service to perception. Dante, in his Divine Comedy, reminds us of the crucial role of memory. Open your mind to what I shall reveal to you, and keep it there, for to have heard without retention does not constitute knowledge. Important properties in this case include, for instance, the qualia access time, how quickly stored quale may be accessed by the upper layers of resilience. The quality of the perception services is expressed through so-called powers of representation, a concept which was first introduced by Leibniz. PORs may be used to compare the perception of essences. For instance, in this case, we can tell that both A and B have limited perception and that the two powers of representations are not comparable with one another. We must consider that these diagrams mutate with time. They may inflate or shrink. In other words, PORs are dynamic systems. Powers of representation may be useful also to compare essences and ambients. For instance, let us suppose that essence A is deployed in ambient B. In this case, the diagram tells us that A perceives only a subset of B's context. Thus, there are changes that won't be perceived. Thus, they won't be reacted upon. The diagram also tells us that A perceives changes that will not occur in B. Thus, there is system complexity in A that does not serve any useful purpose in B. Let me use the following notation to tell that X is an essence or an ambient. Let us suppose that POR of A is a subset of POR of B. Then, if both A and B are essences, the diagram tells us that POR of A is less than POR of B. But if A is an ambient and B is deployed in A, then this tells us that B is not jeopardized, and that, on the other hand, B is over-designed with respect to A. In the opposite case, that is, if B is an ambient, the diagram tells us that A is in danger of not perceiving sensible changes. A perception is the ability to make use of accrued knowledge to come up with models of the current situations. Obviously, a perception is not perfect and only provides us with a limited view to the current situation. The following famous incipit from a tale by H.P. Lovecraft reminds us of our limitations. It also argues that this might be a relief, which of course is debatable. Several great scholars propose classifications of behaviors and systems. Particularly interesting in the context of this presentation are the works by Rosenbluth and Balding. Their lessons may be summarized as follows. A perception appears in essences that produce teleological behaviors, reactive behaviors that is, and in essences characterized by predictive behaviors of different orders, the order being the amount of context figures that are taken into account while predicting. If we call teleological behaviors as zero-order predictive behaviors, then we can make use of this integer, the predictive order, as an apperception metric to compare essences with one another. The third constituent of resilience, we conjecture, is what we call Entelechism, namely the mechanisms responsible for planning and controlling the robust emergence of resilience. In a resilient MAPE-K loop essence, this is the planner. The resilience planner is obviously an essence in itself. Thus, the apperception of these essences may be also subjected to classification and ranking. What we call as meta-apperception is then the apperception of an essence planning subsystem. It is worth remarking how the productivity order of an essence will in general be different from that of its planner. For instance, in the cited paper, we have a one-order predictive essence with a teleological planner. A second important factor to be considered is given by the number of planners and their organization. In the case the planners are more than one, we conjecture it is particularly important to consider the social nature of the interactions among planners and the organization of control among planners. The first dimension tells us how decisions are made, in isolation or otherwise. Interestingly enough, social context decisions are not typical of complex essences. Bacillus subtilis, for instance, are very simple beings. Despite said simplicity, they make use of complex collective behaviors, for instance quorum sensing, to choose between cooperative and selfish strategies. A second dimension, we reckon, is given by the way the planners organize resilience control. Several options are open, each characterized by positive and negative aspects. Particularly intriguing is the case of biologically inspired distributed organizations, in that they organize planners as a hierarchy of autonomous entities. So we get to the third and possibly most important question. How can we use resilience classes to design resilient essences? A major conjecture here is that decomposing resilience into sub-properties and classifying essences and ambients accordingly makes it easier to reason about essence-ambient fits and to resiliently self-adapt an essence with respect to a reference ambient. This ability is what I call autoresilience, the ability, that is, to select perception, apperception, and intellectual organs best matching the current environmental conditions through a continuous and autonomous dynamic process. As an example of a practical way to achieve autoresilience, let me introduce you the elements of an admission control mechanism between an essence and an intended deployment ambient. The idea is that both essence and ambient publish their resilience characteristics. This allows the essence's resilience figures to be matched with the expected minimal resilience requirement of the hosting ambient. Something like a resilience contract to be matched with an ambient policy. Let us consider a classic example of this, what is known in English as the canary in the coal mine. In this case we have two essences, the miner and the canary, that are obviously very different with respect to resilience. Miner appears to be characterized by superior resilience, higher perception, stronger apperception, and more sophisticated Entelechism. But resilience is no absolute property, in that it requires to be matched with a reference environment. Suppose we have as ambient a mine. Mines are characterized by occasional presence of toxic gases, for instance carbon monoxide, carbon dioxide, or methane. When this is the case, the miner results under-designed. In fact, the miner that the minor's power of representation does not include the perception of toxic gases, which means that the minor may not react in time. A classic solution is that the minor brings along a canary. If the minor watches the canary carefully enough, this effectively enhances the minor's perception. This diagram describes the various powers of representation at play: minor, minor plus canary, and mine. Now, if perception of toxic gases is here, minor plus canary will be able to perceive the gases and thus, hopefully, react in time. So we get to the conclusions. My main lesson learned is this one. We need to observe and learn from nature, which means studying all cases of mutualistic relationships and collective strategies that allow our resilience figures to be extended. Collaboration is the only way for a biological species to prolong its existence. The case is slightly different with non-biological essences. There we have two options. As biological species do, also computer-run essences can make use of mutualistic approaches. But they also have the option of self-evolve, which regrettably is a much slower process in biological essences. By enacting these two options, computer-based essences may effectively be made able to manage the complex trade-offs corresponding to these two options. As already mentioned, the main purpose of this work is to initiate a discussion on autoresilience. In fact, much is yet to be done. My plans currently include the definition of design principles for autoresilience, dynamic composition of essences and planners via transformer, and the dynamic definition and management of collective resilience strategies via fractal social organizations and their social overlay networks. This concludes my presentation. Let me thank you very much for your attention and wish you once again a great day.